On example 5, find the slope of the secant line through P and Q. We've done this before. This is hardly calculus. We want to find the slope of this graphed segment here. And notice that instead of what we had before, we have this variable point here at Q. It's x comma f of x. And then our secondary point to complete our secant line pair, we have a comma f of a. We will save this question for after we're done with the slope. Let's try this. So our slope, oh my gosh. All right, let me try again. Eraser was selected. Our slope is a change in y over change in x. Our changing y, let's keep it in this order. Let's do the f of x part first. Minus f of a. And then in the same order, x minus a. And we're done. And now we can ask the follow-up question, or maybe even try to answer it. What would happen to this slope as x approaches a? So as x gets closer and closer to a, in other words, I would plug a in here, I'd get 0 over 0. But as this a value, this x and this a value get closer and closer together, then point P and point Q are going to get closer and closer together, thereby giving us the tangent line again, or the slope of the tangent line at any particular point. This sounds to me sort of like an alternative definition for the slope of a tangent line. Yep, it sure is. So let's write this one up too, shall we? The tangent line to the graph of y equals f of x at the point P, a comma f of a, is a line through point P with slope, boop, m is equal to the limit as x approaches a of f of x minus f of a over x minus a. Now, I want you to have some exposure with both of them because the AP calculus test, it's going to mix it up on you. Sometimes they're going to give you this one. Sometimes they're going to give you the one that we were looking at before. And the point we'll be able to make is we can solve it in either one of these forms. And sometimes, just occasionally, one of the forms works better than another form. And, well, let's give it a try. Let's give it a try on this example 6 here. Write the equation of the line tangent to the graph f of x equals 3 over x at 3, 1. So it's the same kind of stuff we've been doing. All this objective except for, let's go ahead and practice the alternative definition here. So on this one, I'm going to still set it up with like a blueprint first and then plug my stuff into my formula. I'm going to do it in kind of 2 steps. Now, instead of h going to 0, that's not what we're doing here. Remember, it's x goes to a. And my a value for this particular question is 3. So I want to make this x approaches 3 of f of x minus f of 3 over x minus 3, right? Just like this, where, again, once again, the a value here and here is supposed to be 3. Now let's plug our 3 into our function, and I would get my function. This is the f of x. That's just going to go right there. So this is the limit as x goes to 3 of 3 over x minus, well, I don't even have to plug this into the equation. I already gave it to me. It's 1 over x minus 3. If you were to right now, at this particular juncture, substitute in a 3 for your x, you'd have 3 divided by 3 is 1. 1 minus 1 is 0 up top. And then 3 minus 3, another 0 on the bottom. It's an indeterminate form, which we're going to fix by, well, look, there's fractions. I think I'm going to deal with a common denominator. Let's multiply by a fancy one called x over x. And then we'll distribute that x across the top to both of those pieces. And as we usually do, just keep the bottom in factored form. Limit as x approaches 3 of, I would have 3 over x, this 3 over x times this x, and the x's will cancel. Let me just go ahead and do that in 2 different steps. And then minus x, negative 1 times x, over, keep it in parentheses. All right, And I just did that just, for some of us who still need to see something. Cancel out the x's. And up top, I have 3 minus x. Right, so I have the limit as x goes to 3 of 3 minus x over x times x minus 3. Well, wait a minute. Nothing cancels out this time. They're not exactly the same. However, we can make this one up top look like the one on the bottom as long as we, if we just factor out a -1. So let's try that. Limit as x goes to 3, factor out a -1, or just, a negative sign. And across the top, it would just basically switch the signs of these. It'd be a -3 and a positive x. I'm just going to switch the order of them too and make it x minus 3 over x times x minus 3. And now I can see that they definitely cancel, leaving a 1 up top, actually a -1. Limit as x goes to 3 of -1 over x. Plug in your 3. Pretty sure you just get -1 third. It did want the equation of the tangent line. Right here, the equation of the tangent line. So I just need a point. I already have my slope, so putting them both together, y minus 1 is equal to -1 third times x minus 3. Do I have to do anything else with it? No, man. You're just wasting your time. Just wasting your time. And I don't have to match it up with anything, so it's good. So as a result of this particular question, I will show you maybe a little pro tip here. When you have something like this, x minus a divided by a minus x, this is essentially the kind of thing that we had here. And I could go through the effort of factoring out a negative, or just in general, this is equal to -1 everywhere. X is not equal to a, right? Again, because I would have factored out a -1, just like in this example, and then the two factors would cancel. All right, that is absolutely the conclusion of the first objective, being able to use the limit definition to find the slope of a tangent line.